How are you guys doing? How was lunch? Is everyone full? That's great. It's always nice to be full. Hey, welcome. Thank you for joining us. So, you can all see this title. Today, I'm showing you guys how we build an app with only a database. But I'm not only here to talk to you about databases and apps. I'm here to talk to you about rules. We live in an industry defined by conventions, by rules, best practices, frameworks, stacks, and a sense that if you stray too far from the right thing to do, you're doing something completely wrong. It's like we have no wiggle room. But think about this: some of the best inventions, the inventions that move us forward, actually came from people who broke the rules. They defied the convention and they came up with their own, and they allowed us to create something new and really innovative. Centuries ago, this is what we thought our solar system looked like. Is we thought we were the center of the universe, that the earth revolved around nothing and everything revolved around us. That was the convention. Until a man by the name of Galileo invented the telescope. Yes, when he took this little piece of glass, stacked a few lenses together, put it up to the sky, and what he saw was revolutionary, and it changed the way we look at everything about humanity. We weren't the center of everything. Yes, we were just a tiny part in this massive system. And to this day, this is how we see the universe, and this is how we see our place in the universe. Since the dawn of humanity, humans have always wanted to fly. We had this lust for flight. And we always thought that controlled, powered human flight would be impossible. Until two brothers by the names of, what are their names? Orville and Wilbur Wright. They uh, invented the first ever aircraft. And this aircraft could carry humans. It was in the year 1903. And they even built their own wind tunnel, which they used to test ideas and form the basis of modern aerodynamics. And to do this, they ignored many people, experts who said, no, this isn't going to work. They defied the convention and they came up with something amazing. So let's fast forward a few decades. We all know this man, Mr. Alan Turing. During World War II, Alan Turing built machines to break codes sent by the Nazis to aid in the fight. And he also came up with many theories, one of which was the idea that a machine could simulate another machine. He came up with this concept, the universal machine. And at this time, this was unheard of. The idea you could simulate a computer with a computer, this would never work, but it did. And this became the basis of modern computing. And after this, the first computers emerged. We had machines like the ENIAC, the Colossus, the Z1. They were built for military, they were built for governments, and this was the foundation. But this was only for the military, for governments. It was so complicated. No one knew how to use it. And the convention was always, oh, computers are not for the everyday man. But then Steve Jobs came along a few decades later, and he modernized the graphical user interface. And this is what really brought computing into the mainstream, into the hands of the average consumer. And again, he defied the convention. When the Macintosh launched, it had great design, it had great usability, it was intuitive. And that way anyone could use it, from a government official to the average student at home. And it brought so much accessibility, and we wouldn't have the machines we have today if it weren't for this. So the point I'm trying to make here is that all of these inventions, these ones that brought us to where we are now, came from people who didn't take the conventional route. They asked, what if there was another way to do something? And you realize that a lot of transformative inventions come when you actually break the rules. And when I say break the rules, you don't go all the way in the opposite direction, but you try something different. And sometimes you create something great. And we see that a lot in tech. And that's one of the reasons why I love working in the tech industry. So my name is Rahul. I'm a software engineer and I work at BBD. And something about me is that aside from my day job, I love working on side projects. I always have. Since I was a child, I always liked doing different things, tweaking things here and there. And they started with weird things, from weird ways I would fold paper. And then when I got a bit older, I made a Minecraft mod. And it was really weird because I wanted a red colored fence. And Minecraft didn't have that. So I asked myself, why don't I do it on my own? And I did it, and it broke. And I was like 12, but it was fun. And I moved on to doing things like productivity apps. And this love for side projects also led me down a rabbit hole of research. And when I was in university, yes, I looked into playing around with machine learning, and I actually ended up getting my master's in computer science, where I researched evolutionary algorithms and convolutional neural networks. And I had a blast. And I realized that at heart, I'm not only a software engineer, but I'm also a researcher. As part of my day job, I am what we call a full stack engineer. What does that mean? What it basically means is I don't break the search page on Google. I don't break Google's database. I don't break the server. I break all three. That's what full stack engineers do. But that's what makes it fun, because when you break something, you have to learn really quickly how to fix it. Otherwise, you lose your job. So it's very important. That's what a full stack engineer kind of does, but it's still a little bit complex for those of you who may not be as technical, right? What do we mean by full stack, or what is a stack? Am I talking about a stack of pancakes or something? No. So most modern pieces of software, especially on the commercial end, are built in parts. And it's these parts, when connected together, form a whole even greater than their sum. So take a website like Google, right? It has a search page, and let's walk through how we actually do a Google search. I want to find my favorite song. So I'm going to type the name of a song on Google search. And this is where I start. And this screen that does my searching, along with if I open up my Gmail or if I view images, we refer to all of these screens as the front end of an application. And what we do then is we take our search, and our search query gets sent somewhere. Yes, and our search query has to be processed and handled and delivered back to us so we can get our results. So this is where what we call the back end comes into play. And the back end refers to a server or something that handles a bunch of logic. So if I search something, I want to figure out, hey, am I typing in the correct thing? Or am I using the correct characters? Or where should I actually look for the information? That's in the back end. Yes, it processes your search, sends it back to the user. But during this process, there needs to be some kind of place to store your data. When I log in, where does my session go? Where do I store my emails? Where do I store search results? Where do I store all of these things? Well, we store them in a database. And the back end basically retrieves data, sends data, and manipulates data in your database. So what happens is your search query goes from your front end to the back end, processes, fetches any data, receives the data, sends the result back to the front end, and then I can see my favorite song. That's how the process works. And typically what we have is our front end, our back end, and our database will all kind of sit on a separate machine. Could be in the cloud, could be somewhere, but they'll sit on a separate server. And that's how all of these servers talk to each other. And that, the front end, back end, and the database, along with a couple of other things, is what we refer to as the stack. Right? So hopefully everyone kind of knows what a stack is now. Unless you're sleepy from lunch, it's okay. But this is the stack. And this is why full stack engineers break every part of it. There's a lot of moving parts. And the more I talk about this, the more I ask myself, why? Why are there so many parts? Doesn't it create more failure points? Doesn't it cause more maintenance? Doesn't it mean we have to do so much more work? And us devs, we love not doing work. So why don't I do something above weird? What if we didn't have it? So I thought about this and I realized I can't just write this out. I have to do some kind of experiment. And I'm fascinated by doing experiments. I love taking an idea that sounds a little bit ridiculous, pulling on that thread and seeing just how far I can stretch it and seeing what it unravels into. And that curiosity, along with what I do as part of my day job, led me to the question of what if I built a full stack app without a stack? Or more specifically, we have to store it somewhere. We need to store our data. Code is data. Everything is data. We need something. So what if I took the stack away and I used only one thing? What if I built an app with only the database? How hard can it be? The age-old question. So no dedicated hosting for each component. Such a waste of time, man. It's just almost entirely pure SQL. Tiny bit of JavaScript and a stubborn determination to see how far I can actually stretch this idea. So let's do it. So just to clarify, what we're going to do is we're going to take our front end, back end database, we're going to scrap it and have only a database. And what's going to happen is our front end code and our logic is going to sit inside our DB. What on earth? How does this work? Where's everything? The front end, back end, and database all become one. It's going to be fun. So before I start, let me be clear about something. A lot of us are software engineers here. Please don't do this on your commercial banking app. Okay? I will not be held liable for anything that may happen. But that's exactly why it's worth exploring. So we can't do this on our big commercial pieces of code, so we can't learn from them, right? But have you ever thought, like, what if we just tried something like this? Because when you break these conventions, is you understand why the conventions are there in the first place. And if you live in Johannesburg, you know if we break the convention, is we know why the conventions are there in the first place. So, moving on. As part of my day job, I work on a bunch of different projects. I work for multiple clients, so I do multiple things. And this happens throughout the day, multiple days, multiple weeks. Projects stretch on forever. And because my brain is not the largest in the world, it can only process a certain amount of information. I need a way to record exactly what I'm doing for each client, right? So I don't forget, I get things done on time, and I just have a good mental picture of what I have to do and what's done. So I'm sure most of us have the same problem. Most of us would write a to-do list or have an Excel spreadsheet. Oh, but guys, Microsoft Office is expensive, eh? So I'm not going to do that. I'm going to do the perfectly normal thing. I'm going to build an app. And my app is going to allow me to basically note down what I have to do for each of my projects. So it's nothing too complicated, but let's clarify quickly what I'm going to build for you guys. So I have a client, and for my client, I may have a few notes to write. Finish project A, finish writing the database script, finish doing whatever, finish having lunch with the client so we keep the contract, those kind of things, right? So what I'm building here is a mini CRM, mini customer relationship management tool. It's going to store clients and their notes, and it's going to be very basic. It's going to use vanilla HTML, CSS, and JavaScript. For those of you who don't know what that is, it's a fancy way of saying it's how websites work. So we're going to build a little web application, basically. But here's where it gets spicy, because we're going to use a tool called Postgres, right? And what this tool does is it takes a database and it exposes the database itself as a REST API, right? And basically acts as your read-write engine. So that way it contains all of the business logic, everything like that, and all of your code and all of your logic sits inside your PostgreSQL database. Very simple, right? 1 DB, everything happens within the DB itself. So everything you see, every pixel comes out of your database. So before I show you code, let me explain how this is even possible. So let's have a look, right? Firstly, we know what we're doing. We have our clients, we have nodes for the clients, right? First, I have to know, how do I store this? Because if I can't store this, I can't write my app. So this is very basic database work. But if I want to store clients and nodes, for example, I'll have a table in my DB. I'll have clients and some information about the client. In this case, I just have a name and an email address and a timestamp. Nothing crazy, but you guys catch the drift. Here's some example data of what clients I could have. Okay. Same thing with nodes. A client can have multiple nodes. So you're going to have a reference to a client here. And you're just going to have the content of your nodes. Right? Basic. Nothing crazy. Here's an example of some nodes that I could have. Right? And here's how the tables relate to each other. Grade 11 database homework, right? Nothing too complicated. So remember, everything is sitting in the DB. So we've done our clients, we've done our nodes, right? But where's the code going to go? How am I going to store my code? I don't have a separate front end. And here's the fun. We have a table called files. And in my files table, I have a few things. I have the path to the file. For example, /index.html. That's a path. I have a content type, which is a MIME type. So for example, HTML, I think, is what? Text HTML. JavaScript is application JavaScript. CSS is text CSS. Why do I have this? I'll tell you very soon. Then I have the file stored in binary in my database. So I hope you guys are starting to see the picture now. My front-end files sit in my DB. Yeah, that's going to be fun. So here's an example of how the files will look. Again, path to the file, the MIME type, and then binary. Yes, I obviously can't show binary on the screen. It's going to take up too much space unless you want me to read for the whole day. So again, I mentioned we're using a tool called Postgres, right, which exposes your DB as a REST API. But how does it work? Because I'm sure most of you haven't used it before. So let's quickly see how we get it set up and what actually happens. So Postgres is an open source tool that automatically turns any Postgres DB into a REST API. So basically what happens is you're making HTTP requests and getting responses directly to your database. Nothing else, right? You control access using database roles defined in your Postgres server, and you control permissions. And what this is designed for, it's designed for data-driven apps. You can even handle authentication using your Postgres roles and your Postgres permissions. It's very lightweight and it's great for data-driven apps, but it's not designed for what I'm trying to do very clearly. And that's because, I'll show you very soon, but we'll make it work. So to install it, you just go to the GitHub page and there you download one of their binaries. Yes, you don't, it's just a single executable, so you don't have to install anything. You throw it in your C drive, you hook it up to your path, and you can use it. The way you use it is you have a config file, which I'll show you in the next slide, but yes, you run it with that command, postgres in your terminal, followed by your config file, right? A config file looks something like this. All it is, it's your database URL, and then information about your schema and the user that you're using. And you can also set things for course and for JWTs. And in this case, I haven't done that just for the purposes of the demo, but it's quite robust. It has everything you need in one file. So once it's running, you have your REST API. And the way it works is that you make an HTTP request. So in this case, I make a HTTP GET request with clients as my URL parameter. And what it does is it runs a select query on your client's table and returns the data back to you. Quite simple, right? Here's kind of how you would configure your database user and your roles. For example, you can see over here, I create a role, I call it API user, and I grant it a bunch of usage information. So it can perform CRUD operations on my table, that kind of stuff. That way, when I make the HTTP request with the specified user, I get my responses that I want. Yeah. So again, here's how we get our clients by making an HTTP request. But how do I get my files? Because that's how it's going to work, right? I'm going to get my HTML from my DB and I'm going to render it into my browser. So if I try getting my files, we have a small problem. This is what happens. We get our content, right? You may think, oh, it's okay, but I'm sure most of you can see this is JSON. How do I get JSON to render as a web page in my web browser? Remember I said a tiny bit of JavaScript? Well, this is where the tiny bit of JavaScript comes in. So I wrote a small proxy file, which basically queries my DB, gets my file, uses the MIME type to figure out what file it is, sets the header, and renders it to my screen. Does that make sense? Perfect, right? Yes, and this is how it works. So let's look at some code. Just want a sip of water. Okay, let's start with my proxy. Remember I told you we need something to render the files in the web browser. Very simple. So all we do is we have our database and we make our queries, we get our data, we attach the headers, and we render it to the browser. Very simple. I'm not going to bore you guys. Yes. Here's how we serve our index.html, right? Just with a basic app.get. And here's an example of how my index.html looks. Right? What am I doing here? I've got a script inside my HTML page. And what my script does is it dynamically renders in all of my clients and all of my nodes. Right? Nothing too crazy. Very simple. I'm sure most of you guys can do this. We fetch our clients, we fetch our nodes from the DB, and then we can render them in. Because all we do is we dynamically create HTML elements and we append to the DOM. It's nothing crazy. So we do the same thing with nodes. And yeah, that's basically it. That's the app sitting within the DB. But how do we do this? Let's say I update my front-end code. How do I update my front-end code in my database? How do I actually deploy a new version of my front end? I have to do something like this, where basically what I do is I connect to my database and I run an update query on my table with the file that's sitting in my local file system. And that is my pipeline. So yeah, it works. It works for me. So let's actually see the code in action. Okay. Index.html should be showing on screen. Perfect. There haven't been a lot of coding demos today. Eh? Well, let's hope this works. All right. So I'm in the root of my project. Here's my front end code. Index.html is here. Let me just zoom in. Okay. App.js is here. Let's go back to the top. Yeah, the same stuff I basically showed you guys on the slides. We have a CSS file here for styling, which I'm going to play around a little bit. That's right. And then we've got some predefined SQL statements. It's nothing crazy. What I'm going to do now is I'm actually going to start my server. So I have my PostgreSQL server running. Here's this query where I select all of my clients. You guys can see all of my clients here. Let's try select files. And if I run, here's my files. They're in my database. So now I'm going to start my Postgres server. To do that, Postgres and my config file, and it's running. I'm going to now open up another terminal because remember, we have to run my proxy. So we're going to, let me just do this. We're going to cd into my server directory, because that's where the proxy.js sits. And we're going to say node proxy.js, and it's running at localhost 3000. So let me just do this. And here's my app. I can see my clients. I can add a new client if I want. I click on a client and I have notes. So first of all, I'm sure some of you don't trust me. Probably think it's just running in VS Code, right? So let's do something. Let me show you it's actually running from within the database. How am I going to do that? Right. Styles.css. We see a background here, right? I have two different backgrounds. I'm going to comment out this one. I'm going to comment in this one, and I'm going to save. Then I'm going to turn off my proxy. I'm going to turn off Postgres. If I try and refresh here, it's going to fail. Right. I'm going to restart Postgres. I'm going to restart my proxy. Oh, it hasn't changed. I hope that's some proof, but let me show you a bit more proof. We changed the content of the CSS file. I told you how I deploy with this wonderful update CSS file.js here, which connects to my database and is going to run an upsert query here, right? Connects, runs the query, and updates the file. So let's do this. What I'm actually going to do is I'm going to open up another terminal, and I'm going to cd into the server directory, and I'm going to say node update css file.js, run, refresh. There. Okay. So you guys now know it's running in the DB. So let's click on a client. Let me add a note here. Finish project. Add the note. Let's go back. Let's refresh. My data persists in my database. So what it's doing is it's obviously running an insert query from my JavaScript file. It's working, right? So we know it works. But this works for me. Will this work for a bunch of people? Is it going to work if we have multiple people connecting to the DB at the same time? Or is it going to work if we have simultaneous requests, or if my database crashes, what happens to my front end? So let's play around with a few things. I have a file here with some fancy code. I call this a thundering herd. So what I did is, if we go to my proxy, let me find it. Herd direct. I've created an endpoint that basically opens direct sessions to my database to simulate a bunch of people connecting to my server at the same time, right? So all it does is it takes counts for how many requests you want, how many seconds you want them to last. And I'm going to use this to basically show you guys what happens if I simulate multiple people connecting. So here we go. What we're going to do is we're going to open 50 connections. We're going to make them last 20 seconds each. Let's do that. If this even works. There we go. This is running. Right. I've got some SQL here, which I'm going to run to show you guys how many connections are running simultaneously. See, we have 51 active connections currently to my DB. Let me change this number to 500. Oh, crash. Let's do this again. We have 96 simultaneous connections. So clearly the server limits itself at like 100. We could probably reconfigure this, but my DB has crashed, right? Which is not a good thing. Do you want this happening in production? Yeah. We create a single point of failure, and that's also going to affect write requests, updates, etc. That's the first problem, right? Let me show you something else. Take a look at this. we have a very pretty, very nice looking website, right? But remember how this works. The API makes an HTTP request to the database. It makes a GET request to select. It makes a put or patch request to update. And it makes a delete request to delete. So I want to go and delete a note. There's no notes here. I want to delete this note. Okay, I'll delete the note. Yes, the note is gone, right? What happens if I try deleting a file? What do you think is going to happen? So I have a curl here to set a delete request to my CSS file. Let's do that. Who needs CSS anyway? Oh, what happened? Null, null, permission denied. If I go back, my CSS is still there. That is because, like I said earlier, Postgres actually has a little bit of authentication built in, right? But how many of you guys in dev create a user with admin privileges just to test? And how many of you guys sometimes forget when you push the prod? Right? So let's go and give our user delete permission. Right? It's going to be this one here. Oh, this is revoke. Where's the grant? Grant on file. So we're going to grant delete as well on my files table. So if I do this, do that, oh, it was granted, right? Now let's do the curl. Oh, now imagine this was a production app and I use my terminal to do this. And then your boss comes and logs into the system tomorrow and he sees this. Oh, I feel bad for the UI UX if they don't. There's going to be problems here. So how do I fix this now? I have a deployment pipeline. Deployment pipeline, right? So let's go back into server. Let's update my CSS file. That looks a bit janky, but it's back. Yeah. So that was my little app. Yeah, that's basically my code. So where is my clicker? It is here. Oh, there's a chair. Here. So I showed you guys the app. We saw it in action. Now, did I just prove that you should run your company's mission critical software this way? No. Please don't. Okay. We've seen the app. It works. And honestly, for my use case, it works quite well, right? I can do what I need to do. I can add my clients. I can add my nodes. I can extend this to have deadlines. I can use cron jobs to send me notifications. I can do a bunch of stuff. And it will work for me. So I'm just one user. And my use case is light. There aren't hundreds of concurrent requests. We saw what happens if they were. There's no complex access control. And we saw what happens if we mess with access control. I'm just working with what Postgres gives me. And my amount of storage is minimal, right? What if I flooded this thing and I made my database too large? And then what if my front end starts to lag because I don't have enough CPU usage, right? So I'm not syncing across devices. I'm not tracking real-time updates. And the app is not under load, right? And for this scenario, single user tool, it works. But the moment we take this into the multi-user standpoint, that's fine. That's fine. The moment we take this into a multiple user scenario is when it starts to fail, right? Because we have to handle so many different things. We have to handle authentication for multiple users logging in, which means we have to create multiple database roles. We have to make sure we have enough CPU utilization, enough RAM, and enough storage for the data in the first place. So we can start to see the cracks here, right? And basic things like, content delivery is if I wanted to do an A/B test, how am I going to do it? There are a lot of things that aren't going to work very well. And let's talk about deployment, right? In a typical scenario, you deploy your back end and front end independently, right? Usually in a container or behind a server, something like that. But my deployment pipeline is a SQL insert. Yes, go tell the bank executives that. Wow, they're not going to be happy. But yes, I updated the app's files by modifying rows in a database table. It worked, but it's not going to work for everyone. So at the end of the day, why did I do this? I did this because I learned things you can only learn from going beyond the convention and trying to break the rules. I learned why separation of concerns matters. I created a single point of failure with this database. Right? It worked for me, but it would be better to split it up if we had multiple users. But I would never have known that if I didn't try it. Right? I learned how I can still build something practical given my constraints, because it does work and I have no issues with it. So we've seen how it works, we've seen how it doesn't work. And here's a question I want to leave all of you with today. And that question is, what would you learn if you try to think outside the box? Because as engineers in our jobs, it can be very easy to start having a very repetitive cycle where we get up, we do the same things for the same client, and we don't question things. But when you forget to question things, you don't learn. What would you learn if you broke the convention? Because when you learn how those conventions work, when you learn how they start, when you learn how they've evolved, that's when you really start to figure out why we have them in the first place. And that's what equips you to create amazing things in the future. So we're never going to innovate if we don't try break things. So we're never going to learn and we're never going to improve if we don't try and look beyond what we have already. So I urge every single one of you, examine the rules that you have in your day-to-day working life. Figure out what you could try and bend just a little bit, because you could end up creating the next most incredible thing. And I can't wait to see what all of you create. Thank you very much. Questions? Any questions? I can't see because of the light, so yeah. Oh, Mike is coming.
Was Postgres the most lightweight database you can find? Why did you use Postgres? And do you think there's even a lighter weight option to try something like this?
I'm sure they are. So my research initially, I just decided to use Postgres because I write a lot of PostgreSQL statements anyways. Like I do that in my job. So it just came naturally to use Postgres. But I'm sure there's something out there with SQLite, something like that. I'm sure there's a non-relational variant of this. I'm sure you could write your own, and bake it into your DBMS. But to answer your question, it's because I'm more familiar with Postgres. Yeah. Anything else? I can't see. I think there's a question in the back, but I can't see.
Hello.
Hi.
Interesting presentation. I really enjoyed it. I see other people use Postgres for replacing things like, Redis, RabbitMQ, Elasticsearch, because it does have quite a lot of capabilities in those
Yeah.
regards. If you want to do text search or store, document data,
Yes.
you can do that. And I see a lot of people using the database to replace those other tools.
Yes.
Have you done that, or do you just use it as a database?
No, I haven't done it for that purpose. Because I just decided to use it here for the specific scenario. But I'm not going against the tool. I think it's a great tool. It's just shouldn't be used for what I used it for. So you don't store your front end code in the DB unless you want to learn stuff. But I agree, in terms of replacing Redis or Elasticsearch, something like that, it could be very useful. I guess you'd have to also think about load, security as well. It's that kind of thing. But with the right architecture setup, I don't see it not working. And if you're using it for the correct tables, yes, I think it's a very viable solution. Hope that answers your question.
Thank you.
There's a hand here. I saw that one.
Another issue that I had looking at this kind of system is when I don't even necessarily think it's bad to store the code in the database, right? Because it's kind of when you're deploying really basic static
Yeah.
HTML websites, you're just doing it in like a blob storage anyway,
Yes.
right? And you're
Yes.
accessing it on like AWS.
Yeah.
But if you don't have a server or some kind of thing, then you're going to run into the same problem again, where everything that needs to run code-wise is going to be on the actual site that people are working on
Yes.
and can see. And
Yeah.
so that means that any business logic, anything you might not want to be as visible, that's all going to be
Yes.
straight up there and straight visible, right?
Yeah. I agree. Visibility is a big thing, but I think moreover, the main concern I have with this kind of approach is the single point of failure. Because a front end crashes, you can bring a front end up. But in this case, if the front end crashes, the database crashes. But I do agree with you, yeah. It's not the best for security purposes as well.
Unless you do the solution where you store all your business logic in procs.
Yeah.
That's
You
beautiful,
could do
right?
that. You could definitely do that as well. Anything else? No, I can't see any questions. Please wave your hand frantically if you do have one. Okay. Is there one? No. Okay, I think we're good. Thank you so much, everyone.